This is Ji-Hoon Kim from Altov in Korea company. Anyway, thank you for giving me a chance to present here today. And I really appreciate all those involved for organizing this seminar. Today's topic is case study of intro screen for implementing user context-based AI's kiosk service for accessibility. Okay. Recently, as the number of kiosks increase and accessibility issues for the person with disabilities and the elderly.
Mike is, I think it's.
Okay. I check.
Mike is
This one.
Oh.
not working. But it's recurring. And
It's crossing.
crossing.
That's good. Maybe use it.
Okay. Now, my speaker is already good.
Otherwise, I think it has no battery anymore.
Okay.
If you can, you go because it's no battery.
Okay.
Yeah,
No problem.
battery going to die.
Okay. You need this. We do this. Otherwise, people online.
Okay.
1, 2, 3.
1, 2, 3. Yeah.
Okay.
Thank you. Okay, let's start again. Yeah. Recently, as the number of kiosks increase and accessibility issue for the person with disabilities and the elderly are emerging. As you know, COVID-19 pandemic situation, and the increase of the minimum wage, and the preference for non-face-to-face service may generate the increased number of. Due to the environment changes, persons with disabilities and the elderly have difficulty using kiosks and were alienated from access to kiosk services. So the Korean government has made an effort to solve this issue from 2020. The Ministry of Science and ICT held a public contest, Intelligence Kiosk Barrier-Free Service demonstration project to solve the problem of the socially underprivileged in the use of kiosks. Through this project, a barrier-free kiosk was developed and installed that can be more easily by everyone as well as the elderly and the persons with disabilities. To develop a barrier-free kiosk, first of all, we have to discover the needs of each disability types. From the perspective of physical disabilities, as the screen and payment terminal of kiosk stand high, it is difficult to see, choose, and pay for the product or service. So they need to low screen. In the view of visual impairment, since the information is provided only through the screen, they can't see the icon on the screen and have difficulty in touching the menu button. Therefore, voice guidance will be helpful. Those with hearing disabilities don't prefer to use service provided based on voice. In particular, it is necessary to support sign language for illiterate hearing impaired people who want to use kiosk. And the elderly have difficulty in using kiosk because they have a weak eyesight and hearing problem. Also, they are not familiar with the touch screen of kiosk. They prefer large font screens. To provide accessibility to kiosk for the persons with disabilities and elderly, we define the need and develop customized service for the kiosk with accessibility. Customized services are as shown in the table on the left side, and The picture on the right is an example of product can has actually been developed and how it is used by a person with disabilities. First one is an impaired person using height adjustment, and the right one is a visually impaired person using a braille keypad. All kind of devices developed by Alto. Alto developed four customizable UI screens were developed for each disability types, and the standardization of UI accessibility was also promoted for service expansion. The first one is common UI for general service, and next one is high contrast UI for visually impaired person, and third is low UI for wheelchair user, and the last one is sign language UI for hearing impaired person. ASP is a Digital Accessibility Standardization Forum in Korea, established TTA standard on December 1, 2024. The standard name is User Interface Requirement for Accessibility of Self-Service Kiosk. The purpose, the goal is to provide UI examples and guidance for self-service kiosk that comply with accessibility requirements so that the information vulnerable class, such as the person with disabilities and elderly, can equally use information and to help manufacturer implement them and to provide standard necessary for internal verification. Through this, the burden of manufacturer is reduced, and installation and operation entrepreneur can distribute kiosk with guaranteed accessibility. And ultimately, the end customer can enjoy legitimate convenience. A new challenge. Anyway, we developed the UI and we developed also the standard. But the next generation kiosk should have to adopt AI technology. To involve in the AI kiosk based on understanding of user context, we can utilize image recognition. However, it is difficult to distinguish visual impaired or hearing impaired user by appearance. Customized UI conversion service need image recognition with camera, but there is an issue of accuracy. If a wheelchair user approaches, kiosk convert to low UI. But if a user wearing sunglasses or user wearing hearing aids, kiosk can't decide to convert which mode. Many people wear sunglasses indoor, and also it's difficult to distinguish between AirPod and hearing aid in the ear. To classify visually impaired or hearing impaired was a new challenge for us. So we use multimodal interface technology for solution. When a user approaches, our kiosk provides different information simultaneously through a multimodal interface. First, play an audio message by speaker. Visually impaired, please make a fist at chest height. And second, display a sign language video message on the screen. Hearing impaired, please open your palm at the chest height. After obtaining the information, a visually impaired person make a fist. The kiosk recognize it and switch it to the voice UI. Or if a hearing impaired person opens his palm, the kiosk will recognize it and switch it to the sign language UI. In fact, we had concern that user would be confused if different information was provided. But since everyone focuses only on the content they are interested, we were able to confirm that no one is uncomfortable or misunderstand, even if different messages appear simultaneously. Actually, visual impaired people can't see the sign language, can't see the sign language, and hearing impaired person can't hear the voice message. Also, the ordinary people weren't interested in the two kinds of the message. Actually, visually impaired people can't see the sign language message. Okay. Oh, okay. Okay. By utilizing AI technology, kiosk accessibility can be enhanced. This enhancement is achieved by understanding user context and providing a customized UI tailored to various disability types. To effectively implement this feature, it is important to classify the image data below. To address these challenges, we have explored technology that can classify visually impaired or hearing impaired users on the kiosk intro screen by applying multimodal interface technology. This intro screen provides information in various media formats suitable for individual user groups, allowing each group to adapt the user interface to their specific needs. Based on the interaction response, the kiosk provides a customized UI for them. Our kiosk equipped with multimodal interface technology can offer a more personalized and intuitive user experience. By accurately recognizing the user's context, be it through voice, touch, gesture, or even facial recognition, this kiosk can adapt their interface to meet individual needs and preference. This not only enhances user satisfaction, but also open up a wide range of AI-based service, from personalized recommendation to more efficient customer support. Imagine walking up the kiosk and having it recognize you, greet you by name, and immediately present the services or information you most likely to need. It's a powerful way to make technology more accessible and user-friendly. Okay, this is next generation kiosk with AI technology. The Korea Ministry of Trade, Industry and Energy is promoting the development of domestically produced SoC based on-device AI conversational agent kiosk from 2024. Alto joined the consortium and started developing. We expect to implement generative AI technology with equipped on-device in kiosks. AI technology are as below. Recognition of disabilities, user context understanding, LLM, LVM, ASR, but multilingual interpretation, ultra-light AI device. We are developing next generation kiosk with these kind of technologies. And I hope there will be a place to introduce this new kiosk at the next seminar. Okay, thank you.
Thank you very much, yes, for this presentation. I guess there are comments, questions from the audience, either online or in the room. Yes. You need a mic. Could you get a mic, please?
Yeah.
You will need it.
Sorry. So can I ask for the user context in the recognition of disability?
Yeah.
Or is there other user context we need to consider?
Actually, we focus on the disability types: the visual impairment person, hearing impairment person. We focus on the accessibility and the disability types. So, what impact the general side? AI consider all kinds of message and image. Okay?
Okay, so for me, the user context here, those two bullets, the user context understanding
Yeah.
is the same as the first one, recognition of disability. They
Yeah,
are the
yeah.
same, right?
Yeah, so some of the wheelchair user, we can our kiosk recognize wheelchair user and converted the UI, the lower UI, and give to someone have a sunglass, but sunglass is normally using ordinary people and impaired people. So we can classify. So at that case, we use our technology. Please, the visually impaired person, please make a piece in the chest of the head, and make a kiosk classify the person is a visually impaired person. Converted the UI to the voice UI for visual impaired person.
Sure. I have a second question,
Yeah.
sorry. So you mentioned about a generative large language model to respond to various conversation. So here, can I understand that for generative content from this model, it can be applied directly to different modalities. For example, when I input a content, like you need to tell the user some information, and then it could, based on those contexts, and automatically generate the content, the content to visual disabilities, to hearing disabilities people in automatically, or is still different models for
Actually, our target is AI engine classified automatically the vision impaired person, hearing impaired person. But now we are developing our partner AI company. We are developing now, and the prototype is just classified makeup piece and makeup palm on the kiosk, approaching the kiosk, and then converted the UI. But maybe next year or after next year, or we can provide. We have to make a deep learning for the AI engine, and then our kiosk will classify and will serve the more upgraded version in the near future. Yeah. Okay.
right, just the one how to say, just the one concerns, because the generative AI content, the content generated by those models, it can be wrong.
Wrong.
They cannot be controllable, so it sometimes can be wrong. So this can, in this case, will cause some confusion, or especially for those disabled say disabilities people. So that's one concern. If is on normal people and probably they will check different tools to figure this out. There's some wrong information, but for them, probably this will be, this mistake can be more, how to say, there will be more risk about this.
Yes. Okay, in my opinion, actually, the AI engine, the ChatGPT and Llama, as they have a hallucination.
Yeah,
Is it- sometimes they give wrong information. So our kiosk, the first time the user come to the approach the kiosk give a message to the impaired person. And so actually automatically decision is sometimes wrong. So we provide two kind of option. One is automatically and another is choose make a feast, make a farm, and we have another action gesture for the another disability type. So the user listen or see the display the image and they have action and the kiosk interacted by automatically and the kind of type. Okay. Yeah, so our next model kiosk will be upgraded.
Yes, David.
Thank you. I have several questions, but I'm gonna try and keep them down to a few. My first question is, so you've trained the AI to deal with people who are approaching the device and from a seated position, from a wheelchair or whatever. But so, okay, but there are a lot of people who need that lower UI. So for example, little people who are dwarfs, they tend to be short. They tend to benefit from that lower UI. So either you also have to train your AI for that, or you have to have some sort of button that says, no, I want to use this thing, not that thing. So have you thought through the possibility that there may be situations where it doesn't matter what the AI thinks, the user should be able to just say, no, I want this mode, and just be able to hit a button that turns on that mode.
Okay, our kiosk, the kind of service, our kiosk give the menu button is below. Every screen, the user can choose their mode. One is visual impaired mode, and another is hearing impaired mode, and another is children or wheelchair mode. Touch the wheelchair mode, the UI is very lower UI. Okay, change the lower UI. So our user every time they can select the mode who they want, which they want. Okay.
So now I'm going to nitpick your hearing impaired mode, because there are a large number of deaf and hard of hearing people who don't sign. And then there's minority populations that do. So let me talk about the one group first. So hard of hearing people who use hearing aids, but don't necessarily sign, they might want to use that spoken interface, assuming there's text for the same thing. And so in that case, your kiosk would most benefit a hard of hearing person by being able to support a technology like telecoil or auracast, so that a person's hearing aid can literally connect to the kiosk and then provide additional amplification support so they can more clearly hear directly from your device any oral information. So that's the first side of this is why I don't like your hearing impaired mode, because you're focusing on one very small area of need when there's a much bigger space. The other side of hearing impaired mode isn't really for hearing impaired people. It's for people who are sign fluent. There are hearing people who are sign fluent. Children of deaf adults, hearing children of deaf adults are often sign fluent, grow up and become adults who are sign fluent. Sign language is their first language. So it's really a sign language mode. So your sign language mode, the question I have is your sign language mode conveying information in a sign language? And have you tested it with actual deaf signing people to make sure it actually makes sense to them? Because a lot of times these kinds of generative avatar systems break down when it comes to taking a language like English or Korean or whatever, and then translating it into a sign language like American Sign Language or Korean Sign Language or Japanese Sign Language or whatever. That translation often breaks down, and then the avatar itself is often not very smooth and very understandable. So my second question is, have you tested it with actual deaf signing people?
Actually, this issue is we have to more study and learn actually the sign language is different from the country. So if our kiosk installed in the USA, maybe the sign language, the USA sign language, use the USA sign language and England, the Australia, and so that is a cost issue. The cost issue. Maybe in the near future, AI will solve this issue. Maybe, but nowadays, the present stage, your question is very difficult to solve because every country, the sign language is different, and okay.
No, I know the sign language is different, but I know that's not really the question. The question is understanding whether or not when you produce sign content, does it make sense to signers? It's like when you produce verbal Korean content, would an ordinary Korean understand it? That's the question I'm asking. Anyway, thank you very much for taking my questions.
Okay, thank you.
Thank you very much.
Yeah.
Yeah, thank you very much, and thank you guys for the feedback. What strikes me again is the relationship between what we're doing with the with SC42 with the AI group again. So thank you very much.